Jai Jayendra, Namaste, welcome to my channel. Today we are going to solve the 25th question of the problem solving series, which is based on arrays. So the question is, we need to find the longest consecutive subsequence of an array. So this question has been asked in Amazon, Microsoft and Walmart, and the difficulty level of this question is medium to hard. So let's look at the example. So firstly, we know what is the meaning of subsequence. So there is a difference between subarray and subsequence. Subarray is a kind of subsequence whose elements are contiguous, but subsequence are part of the array or any data structure. So here in this question, we are given an array and we need to find the longest consecutive subsequence. So here we can see that the longest consecutive subsequence is 1, 2, 3 and 4. These are the elements that are coming to, consecutively, and these are part of this array. So the length of this subsequence is 4, so we need to return 4. So in this example, what would be the longest consecutive subsequence? So we can see that 3 and 4 is consecutive, even 1 and 2 is consecutive, and 9 and 10 is consecutive, 20 is not consecutive. What is the maximum length? You can see here also we can see 1, 2, 3 and 4. So this is the consecutive numbers that are the subsequence in the array. So here also the length is 4. So how do we solve this? How do we find the subsequence which are consecutive and are present in the array? What would be the approach? The first approach that comes to the mind is, so these elements are not in a sorted order. So if we sort these elements, then we can check the next element whether it is just greater than 1 or not. For example, if we sort this array, so this array would become 1, 2, 3, 400 and 200. So now if we move and we can see whether the 2 is coming, the next element is it greater than the previous element or not. Just 1 greater than the previous element or not. It is, and we can increase the counter and we will get the size of the till this is valid. We will increase the counter. When it is not valid, we will have the count value, and we will store it as a max value. And if again we see if there is anything, we repeat this, we see this repeated thing, the elements are consecutive, we'll again start increasing count. So count was moved from 4 to 1. Now again count will increase, and we'll see, and we'll have the count value, and if it is greater than the max, then we'll replace max. So in this way we can solve it. So also there is a possibility that the numbers are repeated. So we are going to avoid that case. Suppose there is one more number, say 2 comes again. So if we short it, then 1, 2, 2. So if we follow that pattern, that the next element should be 1 greater than the previous, then it will fail. But it still is a part of this 1, 2, 3, 4 are the subsequence which is present, and that is consecutive. So we should handle that case. How would we handle that case? So once we sort the array, then we will remove the duplicates. So if number is repeated, then we can take an extra vector or extra array, and then we can insert the distinct elements. Okay. So in that way, that space complexity would be order of n. We are taking an extra array, and the time complexity would be order of n log n, because the sorting algorithm's time complexity is order of n log n, and then in one traversal we can find out the maximum. That's very simple. So the one approach is sorting. In this sorting, the time complexity would be order of n log n, and the space complexity would be order of n. Okay, so can we optimize this? Is there any better approach? What can we do? How do we know whether the elements, so whenever we are traversing the arrays, for example this array, so we are traversing it 1, 9, 3, 4. So when we are at 4, how do we know that the previous element, we have already the element which is 1 less than it, or is it a starting point of the consecutive number? How do we know that? How do we keep track of that? So obviously we have learned hashing. We have solved a lot of questions on hashing. So can hashing help us to solve this problem in a better optimized manner. What does hashing do? We'll take extra map or set or anything and we can insert these elements, and then once we insert all those elements we can check in the map in order unit order time whether the element is present or not, the previous element was present or not. Say if we insert all these elements and now when we are again traverse this array, so when we are at 1 we can check whether the previous element, what is next to 1, 0, whether 0 is present or not in the map. If it is not present in the map, what does this mean? That if it is going to have a traversal, then this should be the beginning point of the traversal, right? Because the previous element is not there. So then we can check that, okay, 1 is present in the map, then we will see whether 2 is present in the map or not. Again we see that, okay, 2 is there in the map. Then we see 3 is there in the map. So we will keep on increasing the counter. And once we have got the values of that, how many elements are there, we have the count now. And then we can try it for the next number. So in this way we can solve this problem. But will it be an optimized, so the sorting takes and log n. But here when we are traversing the, when we are first we are storing the elements in the map or set, and we do it in order of n traversal. And the next thing is we are traversing the array. So whenever we find an element which is not present in the array, we check whether that is the start, that could be a starting point. So we check whether the next elements are present or not. So this second part is going to be inside the first loop. But does it make the time complexity to be order of n square? No, it doesn't. Because the maximum it could be or can be is suppose 1. Okay. So here 3, 4, 2, 3, 4, 3 times it would come. Okay. But so we are for 1 we have traversed the loop thrice. But then when we go to 3 or 2 or 9, then this will not, we don't need to traverse the map again, because this won't be the starting point. So in that case we can prove that the order of the time complexity will still be order of n, because we are not going to traverse every time in the map. We are going to traverse in the map only if it is a beginning point, and then we can see how many numbers are there. Okay, so mathematically I can prove that the time complexity would still be order of n only. So let's code this. So what we have decided that we are taking a, say, unordered will be giving us a better time complexity. So unordered set we are taking of integer, and say we name it as s, okay, and then what we do, we insert all the elements in the set. Okay, so set of s dot insert, okay, s dot insert array. So we have taken a set, so anyway the repetition won't be taken, right? Set stores the unique elements. So we have stored it. Now what we do, we traverse the array again, okay, for I equal to 0 to n, and now we see whether if s dot find array of I is equal to s dot end. What does this mean? That the element is not present in the array, right? The element is not present in the set. So in that case, what we do, we we take a j value and store it as array of I. So this is the we have stored this value in j, whatever the element is there, and then we check while j not equal to this while j dot this s dot find j not equal to, okay, so okay, s dot find array of I minus 1, okay, array of I minus 1 if it is equal to n. Not array of I will obviously be present in the set, right? So we need to check the previous element. So array of I minus 1. So if it is not there, so we have this j. If this element is not equal to h dot n, so this will be present, right? So what would we do? We'll have a count value, count equal to 0 and result equal to 0. Okay, so we will increase count. Okay, and then we will also increase j plus plus. Okay, so we will keep on checking whether the next element, say 1 here, 1 was the 1 minus 1, 0 is not present, so we'll go to 2 is present, right? So first 1 count is 0, so 1 is present, so count will increase, then we'll check 2 is present, 3 is present, 4 is present, count's value would be 4, and then when j becomes 5 and then 5 when it is not present, so this would terminate, right? It is equal to n. So when this gets terminated, so we have the count value and the result value would be max of result and count. Okay, and then this we can exit, and yeah, so this will exit and we will return result. Okay, so whatever is the maximum consecutive that we have got will be stored in the result. In this way we will solve this problem using hashing in order of n. And what would be the space complexity? We have taken set, so it would be order of n only. So we have optimized it to order of n time complexity. The link to the question has been given in the description. Please try it yourself and then come to my code walkthrough section.
So here is the code walkthrough section of this longest consecutive sequence problem in the lead code platform. You can see it's asked to solve it in order of n time. So here's our solution that we discussed. So here's the unordered set. We are inserting the numbers and then we are checking for the I minus 1. If it is not present, that means it is the starting point of the sequence. And yeah, we have coded the way we have discussed, and so let's directly submit this. So this worked fine. So let me know in the comment section how was the solution and how was the explanation, and see you all soon in the next video where I'll be explaining the 26th question. Thank you.